Hey, we are live. Hello, everybody. How's everything? Hope everybody's okay at home, I guess, or in any other places. I hope you were enjoying your day. So, good morning, good night, good afternoon. So, beautiful day for all of you, we hope. So, we have today with us Rogerio. I'm mentioning right your name, Rogerio. It's okay.
Rogerio, yeah. Good
Okay.
evening.
From Open J Proxy. So thank you, Rogerio, for having with us this day. So I hope we will have a really nice session. People coming from Brazil, people from Barcelona already in the chat. So very cool thing. I hope everybody will have a great time. So let me for a second introduce the community because we normally do small introductions and then I will pass the microphone to you, Rogerio. So let me see if I can share my screen. Where's the button? I guess it's in here. Yeah. So this is the last slide. Oh my God. I hope you can see the presentation right now of the event. I hope somebody can tell me yes, no.
I can see it. Yeah.
Okay.
I'm
Thank
not
you.
sure that I see in the same view as you, so I don't know if the guys can answer in the chat or
Yeah.
it's not
Well, isn't
reliable.
I think it will work. Yeah. So as I said, thank you very much for coming. This event will be the first one, let's say, jumping on the 2026 year. So I hope we will have very good times this year. So today let me introduce first of all the community. We are from the Barcelona Java Users Group. It's let's say a community based on Java, not only on Java, but we always say that we started with Java. We have made a lot of things related to technologies, and we are basically curious people that we like to work and discuss about technology. And yes, we are also a non-profit organization since 2012, so it's been a long time that we were involved in the open source and the Java ecosystem. What we do is basically discuss work, play, and also help others to grow and also to play around technology. And this is more or less the things that we do. We are going to do today a interesting session from Rogerio. So today will be this, let's say, virtual thing. Probably many of you follow us already from either website, Twitter, YouTube, Flickr, LinkedIn, etc. So follow us. We have many places where you can join us and it will be a pleasure to stay in touch with you if you want to send us some messages, some questions. And yes, we are moving into Luma. That's a thing that to mention always because we want to get rid of Meetup. And that's the thing that you have to be aware. So please grab your QR code in case if you were following previously from Meetup. And of course, we are in Open Collective. If you think that the things that we are doing are make sense, and also you would like to help us just by, I don't know, just paying some euro for helping us to organize something in the future, probably we can grab some stickers or buy some cups or things like this. This is something that we want to, let's say, have for just provide some of the fundings that we need for running, let's say, the committee, which is not so much. And also you can find it there, all the numbers which are basically public. So you will see all the numbers in there. We have been, for the ones that doesn't know anything about us, we have been doing events from different places, different technologies, and also different stacks. So from running a workshop focused on TDD or playing with how to do a full stack application using Badin or running test containers to understand how to the AI can be executed even in your test containers in your test. No? So we have been doing a lot of events from a different perspective, different areas and different technologies. And it's also a pleasure for us to also discuss different solutions. We have already in place our next event that will be 4th of February. We're going to happen, we have Ricardo with us that we will talking about how to decouple your favorite framework from the actual implementation. It will be an in-person event this time. It will be, as I said, on the 4th of February. So please, if you have time, have a look on Luma and you will be able to join us and register there. And yes, we have to say thank you. And this time, we would like to say thank you to the Eclipse Foundation that is providing this application for us, Crowdcast for doing this streaming that we are doing, and also JetBrains that provides us free licenses yeah, free license for all of you. So if any of you want to have an IntelliJ license and you are from the Barcelona Java community, please let us know because we can give you a license if you're interested, right? And apart from that, we always say thank you. We always say, hey, it's a matter of this community, it's a matter of things that you can do, and it's a matter of being here and contribute with us. So if you have any crazy idea, any things that you would like came to your mind and you would like to propose, please join us because it's no more, no less than this community is up to whatever you want to do. And we will be super happy to prepare something or to discuss on something that we would like to, or you would like to contribute. So as we always said, we have a Slack as well. If you want to ping us, it's very straightforward to come say something, and then also we can organize something else in the future. And apart from that, I think I'm done. I only want to thanks again to Rogerio to propose himself to share this session. And apart from that, the stage is yours, Rogerio.
Thank you, Nacho. Just thanks for organizing it. Like I think the work that Nacho and other leaders in Java user groups do is amazing. I think that's what makes Java amazing. Makes the community come together. You know, this sort of stage and people like Nacho that provides this opportunity for people like me to come and talk about subjects is very important, and we really appreciate it, Nacho. Appreciate the Java community group from Barcelona. Hopefully one day I'll go there in person as well to do one in person.
Please let us know if you come to Barcelona. Yes.
Absolutely, yeah. I see some people joining there, like good evening, Felipe, Anu, AGL, welcome, and let's get rocking. I'll just share my screen real quick. And I have a deck of slides. We're gonna be looking at the code soon. Don't you worry, it's not all about slides. Just get the slides up here. Yeah. Can you just confirm you can if you can see my screen already? Nacho, is it up? Sorry, hello. Can you hear me all right? Yeah, great. I see in the chat that you can see. Sorry, I have only one monitor here, so I had to switch to. So yeah, this is the agenda for tonight. Okay, there's a small legal notice that about Rogerio. I moved down, so it's almost at the end of the presentation. No need to talk about me in the beginning. Like let's shorten the presentations and get to the core of the presentation right away. The legal notice basically says that these materials and any other materials presented here, they are free to be used. It's just that the Open J Proxy project is not responsible for how they are used or copied or modified. Right? But you're free to use any images, any materials showed in this presentation. As a quick run through our partners, right? People that are helping OpenJ Proxy grow. So the community, Comunidade Brasil Jug was the first community that embraced the project. So we have them as partners. Switcher API, another open source project for feature management and flag feature management in systems. And Materian, for application security. So it looks for vulnerabilities in open source dependencies. It's very good. We have it integrated in our pipeline. You can see it in our GitHub. It did make our code a lot safer. Cyberjar is a YouTube channel you probably know. If you don't know yet, you're missing because it's a high quality YouTube channel. Java Challengers from our friend Rafael Deonero, Java Champion, is more
more
focused on
focused on
careers.
careers.
And
And
which is
which is
behind the
behind
Eclipse
Eclipse
Bass
Bass
Fish,
Fish,
and they
and they
give
give
great
great
open source
open source
solutions with
solutions
the
within
enterprise
enterprise
support.
support.
Sorry, Nacho,
Sorry, Nacho,
I'm
I'm
hearing an
hearing an
echo.
echo.
Did
Did
anything
anything
change
change
in there?
in there?
There's quite a bit of an echo. Are you hearing me all right?
I
Now it's
noticed
good.
the same. I noticed the same, but I haven't done anything. So it's my fault. It was my fault.
Yeah, in the chat, Felipe is saying that there is some echo. There was some echo, but it's solved now. I think
Okay.
we're good to go. Yeah. Okay. So getting into the bits and bobs of this presentation, like one of the first things we need to look into when we are talking about stateful systems, especially that are difficult to scale, is that there is a limited capacity of CPU. Right? As much as we talk about parallelism and all that, at the end of the day, we have a limited amount of CPUs, right? A limited amount of cores. And if we over parallelize, what is happening there at the hardware level is that the CPU needs to bounce between threads to create this parallelism. Just a second. And what that means is that it needs to save a state of one thread in memory, load the state of another thread. There's pauses. There's a lot of work to orchestrate things. So, and that's why when oftentimes by serializing requests to the CPU, you make it faster, right? Because it doesn't need to bounce between threads. So that's an important concept that we're gonna talk about when we're talking about OJP. And now let's get into a very simple example of how scaling a microservice can affect your database, right? So we have a simple app there, like here it's probably running just in a test environment with a single app instance and 20 connections to the database. The database is very happy, right? 20 connections is easy to manage, but let's say in production, there was a surge in requests for your web service, whatever you're exposing in production. There is a Black Friday, wherever it is, and you started to scaling out your application, right? Because you have a connection pool configured inside your microservice. Every time you scale out your application, a new connection pool is created. Let's say the maximum is 20 connection, but if you're busy, those 20 connections are fully being used. So in our example here is scaled out to 3 instances. Is 60 connections already. The database is starting to get worried, right? Because it was 20, now it's 60. It's growing fast. So if it keeps growing, right, let's say the scaling you configure there on Kubernetes, the auto scaling still requiring more instances. We are at 5 instances. That's 100 connections already. 100 connections is already a lot of connections for a mid-sized database. You need quite a good cluster of database to handle more than 100 of connections. 100 connections is the full of Postgres, so you have an idea. The full maximum Postgres accept. I know that Oracle accepts 1,000. Right? It's a different setup. Right? From Oracle, you would have an entire server, and that's why it can have a much bigger maximum. Now, in our example here, let's say for this fictitious application, when it reaches 8 instances of this application, hammering 20 connections each, the database goes down, goes belly up, right? Before it goes belly up, usually you see a lot of errors like timeouts, and you start seeing queries failing with those timeouts because the database cannot process them anymore. Like it's just too busy switching context and too busy, executing too many things in parallel. And that's the connection we make with the CPU, right? At the end of the day, the database sits in a machine with limited CPUs and limited amount of real parallelism that it can do. Does that mean you can only do the number of core CPUs in parallelism? No, that's not what it means. Because we do know that there are waiting times and you can use more than the number of CPUs. Ballpark figure is like usually 2 times CPU plus a few connections. That's a very rough formula that people tend to use to start. If you don't know where to start your connection pool sizing. So let's say if you have 16 CPU cores, you would have a 35, let's say, maximum connections to the database. Probably would be around the ideal number that you would be using. But of course, that all depends on what you're doing, what your software is doing, and that changes according to what exactly you're sending to those connections in the database. So you always need to test for that. But in our example here, 8 instances with 20 connections each, 160 connections, our database is belly up, crashed. So why OJP came about, what were the questions that we were trying to answer. So the first question is this one that we posed, like how can we elastic scale our apps without overwhelming our databases, and in a way that we don't need to over provision the database? Because you could say that one solution is like, okay, you provision a bigger database, right? And then when you reach these 8 instances, you're going to be able to cope with that. But that incurs in a cost, right? You're gonna be paying for that extra capacity all year round if you only need it in spikes of demand. So that's a cost that you need to incur. And sometimes this is the solution. I've seen companies putting more server, more machinery, and if money is not a problem, that's a solution, right? It's not never a solution that I liked. I always try to look at like what is the best solution, the solution that uses the resources in a manner that you don't waste money per se. Uh, Another question is how can we make it more compatible with different databases? Because the solutions we have out there, like AWS Proxy or PG Bouncer, they're kind of tied or to the database or to the cloud provider. So we didn't have a Java solution that could connect to many databases, that we could deploy in any cloud, and that was fully open source. That didn't exist before OJP. How can we deliver seamless integration with Java apps, right? Like it's a Java solution primarily. And how can we deliver it quick and easy to Java? How can we make it more open source than existing solutions? We briefly talked about that. And can it be developed in Java? We're Java developers, right? Like there was a question there, like should it be developed in Java? And can it have a connection pool as efficient as HIC RCP? RCP is arguably the best connection pool available freely open source, right? And that's the full connection pool that comes with Spring Boot, not without reason. So can we have something as good as HIC RCP for a connection pool? And that's how the OJP solution came about. Like in some morning here in Dublin, I came up with this basic drawing. It was not nice like this. It was more like paper and pen. But the basic concept was, can we implement a server, a gRPC server that holds a HIC RCP connection inside? And that HIC RCP uses the native JDBC drivers to connect to databases. And the advantage of that is that immediately you get compatibility with any major database provider. Right? Every relational database provider will have a JDBC driver to talk to. So immediately you can cover a lot of databases just by using Java, HIC RCP, arguably the best connection pool that we have available, fastest, and JDBC, right, which is but there's very few interfaces, I think, in the market of software engineer that is as battle tested as the JDBC specification and their implementations for this database, especially the more traditional ones. So instead of having the connection pool inside our app, we basically externalize it to a server, a proxy server, and we communicate with this proxy server through a new interface, a gRPC API interface, and we also deliver a JDBC driver. And that JDBC driver is to make it easier for Java applications to connect to our OJP server. Right? So you can just drop our JDBC driver in your application, and everything should work. That's basically the concept. You need to disable, obviously, your connection pool in the app side because you don't need it there anymore. Your connection pool is transported into an external server, which is the OJP proxy server. And by doing that, what happens is, like in the figure, it doesn't matter how many connections you open in the JDBC driver. Those are virtual connections. They become virtual connections or virtual handles. They don't mean real connections to the database. You only allocate a connection to the database when you execute a query or a statement or you start a transaction, things like that, right? When you actually do your work. And that delay on allocating the connection allows OJP server to use the real connections more efficiently, right? Because you don't have a connection allocated just because the app asked for one. You delay a little bit. That someone could argue that that's nanoseconds to milliseconds. But if you ever worked at scale, every nanosecond, every millisecond counts, and every bit that you can do of work somewhere else counts. So these little bits count in the end. And the fact that you move the coordination of the connection pool outside of your app allows you to do this scaling here without killing the database, right? Which produces this picture, right? So if you're using OJP, what basically you could do, like we said about 35, 40, right? Connections for a 16 core. Maybe you have a bigger server or your workload allows you to have a 50 connection maximum. And for this scenario, like there is 160 virtual connections being used by the apps. That's just to say if it was using connection pools, right? But it could have even more. It could be 200, 500. It doesn't really matter at this point because those connections, they are cheap, they're virtual. It's more or less the same nuance that separates real threads to the virtual threads nowadays, right, that we have in Java. It's more or less the same. Right? It's a lot cheaper to have these connections than to have real connections. And that's why we should aim to have less connections really open to the database. So we serialize more the work. We already talked about that. And we can let the apps scale more freely horizontally without the price of potentially overwhelming or creating what we call a connection storm to the database, which is too many connections, too much flow to the database at once. Any questions so far? If someone have any questions before we go forward, please raise them in the chat. If someone can call them out to me, that would be lovely. If not, one more thing I like to mention, and that came from our meetings at the Open J Proxy community. We have a bi-monthly meeting. So every 2 months, we meet up with developers, with people that are helping the community of OJP to talk about the project, where we're going, what we want to do, what people want to do. And people bring their experiences. And this is an experience that came around. Yeah, is there a question there? I heard something. No? Okay. So the distributed monolith, right, is a situation that I think many companies find themselves into, where you start with the aim to migrate everything to microservices, right? And you do your division by context, right? Your context-driven kind of division. And you end up with, let's say, orders, billing, inventory. Like you separate your microservices nicely by context and business functionality. But the database is a different story, right? So in many companies, and we did a little research in our community, like there was many cases where database is not split. Sometimes you have different schemas in the database, sometimes even not even that. Like so the database is a shared resource, it's commonly shared, and is more difficult to split than the app itself. So in many situations, you end up with the microservices split, but the database not split. So it's a common scenario in real life projects. And you end up with all these microservices connecting to one database, right? And for these scenarios, OJP is also a good choice, right? It's not going to solve your problem, right? It's still a bottleneck, single database for all these microservices, but it surely reduces this pressure to the database. So it's a good way to modernize the architecture, because sometimes you cannot change it, right? You reach a point like you don't have funds anymore to do further migration. Like you might end up in a situation like this, that this is your new reality, that distributed monolith is the new reality of the company. Like the budget to migrate was spent, couldn't migrate everything. There's many scenarios where that can lead to this situation. OJP is a good choice to reduce that pressure in the database by multiple microservices. So the previous scenario, the one that we showed here, is with a single microservice. But if you have multiple microservices reaching the same relation to the database, OJP is also a solution to help you control access to sparse resource array, which is the database. A quick comparison in the market, right? Like where OJP sits. And I think this graph explains much of why OJP had to exist. If you see the vertical axis is that database agnosticism, what that means is how many database the proxy and the database proxy supports. And the horizontal axis is how much open source is the solution, right? So you have there sorts of Amazon RDS, Aurora Proxy, ScaleArc, they're not very open source. Then you have Google Cloud Proxy, Alibaba DB Proxy, they are partially open source. Not everything in their solution is open source, and they are bound to their clouds, right? And then you have solutions that are open source, like Proxy SQL or PG Bouncer, but they are tied to one database, like Postgres, in the case of PG Bouncer, or MySQL and MariaDB mostly in case of Proxy SQL. And there is some documentation saying that they are starting supporting Postgres as well. But there is no solution that you could use the same solution for Oracle, let's say DB2, SQL Server, Postgres, MariaDB, all these solutions all in once, or Cockroach DB, you know, like a single solution that is fully open source and that is database agnostic did not exist before OJP. Right? So that was motivator for us to create it. This is just an explanation of that graph, really. We can go further. Another thing that is worth to be mentioned is OJP is majorly a Java solution, right? But it's not thought to be only a Java solution. And that's where the proto buffers and that are used to communicate between the JDBC driver, the OJP JDBC driver and the OJP proxy server come handy. The proto buffers that describe our API, they are multi-language compatible. So what that means is that in theory, you can compile our API and create a client in C++, PHP, Python, Ruby, C#, whatever language that supports proto buffers and gRPC, right, can create a client and talk to OJP server, proxy server. There is a protocol, right? There is a specification for that, but it's possible. And to do simple things, I would say is quite easy. Now, to do complex things, it is complex to develop because, for example, our JDBC driver now does load balancer and does things that does failover between OJP servers. So it does more advanced things. But to create a basic client, I think it would be quite simple to execute things against an OJP server. So if you know one of these languages, you want to start creating a new client for OJP, please feel free. I can help you get started. But it's a good thing to know. Like like we are majorly a Java solution, but there is an intent maybe in the future to create clients for other languages as well. Apologies. OJP delivers a built-in circuit breaker, and just going through what it does is a normal circuit breaker, right? If you heard the pattern before, you're not going to be surprised by what it does. But basically, if everything is fine, it just let the queries flow to the database. If one specific query starts failing repeatedly, and by default it means it failed 3 times in a row. You can configure that. You can put 5, 10, whatever times you find appropriate, or disable the circuit breaker altogether. We provide many configurations, so you can really tweak OJP the way you want. But basically, if a query starts failing repeatedly, what the circuit breaker will do, it will block that query from executing in the database. And again, what that causes is, let's say our scenario there where your database is under pressure, right? It's starting to time out, and especially the longer queries start to time out faster. There is no purpose on sending those queries to the database. They're just going to increase the pressure in the database, will make it, it will increase the likelihood of a catastrophic event like the database crashing. So it's better if we just respond to the client, look, this is the error, like we respond with the last error we got, and don't let that query go to the database, right? That creates a bit of a room for the database to potentially even recover from this rise on demand. That can happen in two scenarios, right? Like you have the scenario that I described where you have a legitimate increase in demand to your service, but it can be also a DDoS attack, right? You might be under a DDoS attack, and the requests are not real requests, but it's trying to render your services unavailable. So OJP works as a back pressure mechanism naturally because it reduces the real number of connections that go to the database. That already is a back pressure mechanism, but also with the built-in circuit breaker. It goes even further. If the database starts failing, starts showing signs of real stress, it will block those queries from reaching the database, and it will create an extra layer of protection, and it might give you the ability to survive potentially a DOS. It's not cannot prevent a DOS, right? If you know enough about DOS, you know that there isn't a single way of preventing DOS attacks. There are measures that you put in place that can make you more tolerant to them, right? And OJP helps on that because it holds this pressure from the database. After a configurable amount of time, which by default is 1 minute, you're going to send one of those queries that were failing to the database and see if that one works, right? If that one returns positively, it goes back to green. If it returns an error, it goes back to open state, which means it doesn't send that query for another minute. So it will come back eventually, sending queries to the database only if the test query on the half open status of the circuit breaker works, right? Moving further, a little bit about some performance tests we did. So we did compare using OJP with not using anything. So the first test we did was 100 threads doing 1 minute with 67 mixed selects, joins, aggregations, updates, etc. We tried to create a good mix in a pre-warmed database, a pre-filled database, not warmed. Sorry, apologies. So what that means is that the database was set before, and there was a seeding process, which we put thousands of records in the database. So it's not an empty database. So we start with the database with some reasonable numbers, and then we execute all these threads with 67 different statements against it. So there was also a failure simulation. We put one query that is incorrect. It has a division by 0, right? And that was to exactly test the circuit breaker, right? So we want to see how the circuit breaker works, because that query would always fail. There was an incorrect division by 0 in the query itself. So if it fails 3 times, the circuit breaker blocks it. That was the goal of that query. And all right, these were the results. So the results were, we can see in the graph on the right, mostly in CPU. That was the core observation we wanted to do. So with OJP, the CPU reached a maximum there of 14.8% of CPU. That's one CPU node with a Postgres run. We made it small in purpose so we could stress it easily. And with direct connections, like not using OJP or nor any connection pool, it reached 61.1%. So reached quite a high number. The average CPU usage with the OJP was 10.3, and we can see here in the left side table. And the average CPU usage of the database was 41% without OJP, so letting connections be open indefinitely, right? Which is the situation in serverless and lambdas, right? In lambdas, you cannot have a connection pool at all. That would be a representation of that. The most surprising thing for us was in the average query duration, because we didn't expect it to be so much better in OJP. Because OJP introduces a man in the middle, per se, an extra hoop in network, we thought that it would be difficult to fully offset that even. But I think with the combination of all the things that I mentioned before, the reduction of parallelism, the circuit breaker refraining that bad query from going to the database, and the better management of the connections by not using the connection when it's asked, just when it's really needed, OJP proved to be a lot faster in these scenarios than just letting connections be open freely. So the average duration with OJP was 31 milliseconds per query. Without it was 55. So it's 40. Like how much there? Almost double, right? Really impressive. Also, the test duration is very, very telling. Like remember, the ramp up was 1 minute. So with OJP finishing 64 seconds, without OJP it took 80 seconds. So you see that the database got stressed, right? Like you had to dangle between all these queries. Too much parallelism. That query that always fails anyway, coming to the database, taking resources. So without protection, that's the difference you see, right? And there was no failures. Sorry, no extra failures. There was 100 failures because 100 threads, and every thread had one query that would fail, which we put there to fail. So that's the expected. There was no extra failures in OJP. That's what we wanted to see, right? It's 100 failures without OJP, 100 failures with OJP. Total queries 6,700 in 1 minute. It's a reasonable test. It's very promising. I think we did further testing that also showed that OJP can increase the lifespan of further of the database. We did further tests with this, increasing the number of threads by 25 threads. So 25, 50, 75, 100, 125, 150. And what happened is that without OJP, it started breaking down at 150. And with OJP, even at 200 threads, with the same test setup, the database was responsive, was pretty stable, and was really nice to see. There is an article in our LinkedIn page if you wanna look those numbers. It's a pretty good thing to look into. I'll give you a few seconds to if there's any questions. If not, I'll show a demo on how we can integrate OJP in Spring Boot.
Hey, Rogerio. Thank you for the presentation. There are some questions already. And I think I shared already back the link about the performance that you was presenting. So the two questions that we have, Anul, hey Anul. So he asked, with protocol buffers enabling non-Java clients, what's the roadmap for official drivers in Java, Kotlin, and any gotchas with big decimal fidelity across languages?
Good question. If there is a roadmap for Kotlin, and I would now correct me if I'm wrong, but doesn't Kotlin work with the Java libraries of JDBC drivers? If it does, our JDBC driver as it is should work in Kotlin. We don't have a roadmap for other languages. I believe our current driver should work in Kotlin. There is no testing for it. That would be great if someone could make a test, report to us, see like, oh, did it work or it didn't work? What's missing to make it work? In relation to other languages like Golang or C#, there is no roadmap. There is an intent. We have recorded intent to do that, but we have too many things right now to do for Java. So we are not yet thinking about different clients. And the big decimal question, very good, very good. There is an entire protocol that developed to make the big decimal be compatible in different languages. It's documented in our repository here. Let me just see if I can quickly find. If I cannot find quickly, I can send it later. But just see if it's. I don't recall now which folder was it. I can quickly find out.
Could be that is on the decision record, architectural
Maybe
ADR.
features. Let me just see in the main point. Link here too. Yeah.
Don't worry, I think
Big
we
decimal
can.
wire format. Is in the first page, is under documents protocol. The only one I didn't look protocol. Yeah, so big decimal wire format. So here is described how exactly we transport big decimals, right? And you can check here. It should be compatible with different languages. So
Nice.
there was it took an entire evaluation just for this type. Very good question. Whoever sent this question is a major question.
Yeah.
The big decimal is the most difficult one to port. So we do have a protocol, and it can be implemented in other languages, translated into their counterparts for big decimal. So we don't, in the beginning, in our first versions, we didn't do this. So we were serializing the Java objects. So before we weren't really compatible with other languages, because basically you would have to serialize a Java type to be able to talk to us. But now no. If you implement these protocols, whatever language you implement it in, it will talk to OJP server, it will work. And it's all gRPC and protobuffers. There is no more Java serialization. There was a big work done there to remove any Java serialization from the protocol. So all gRPC.
Nice.
I hope that answers the question.
I think so. Very nice. I think, and also, in fact, if you want to share this link about this, you can find it as well, and you'll in the protocol folder under the Open J Proxy. So yeah, if you can share it in the,
now.
I think could be really great.
And if you don't get the link, it's in our homepage, right? So if you come to the homepage here, there is a further documents. It's the last one.
Yeah, we have here Anil. Hey, Anil.
Yeah, hello. Thank you for the answer. My intention was to put also Golang and Python as the languages supported, but I hit enter before. So your question is satisfied. Yes.
Very good question indeed. Yeah, like I think I never got this question. Like it shows the level of the audience.
Yeah. We have more people from YouTube, and they are asking a few questions. I guess you're going to answer it in a second, because they are asking how is using OGP from the development of a Java application, if it's necessary to change a lot of source code. I think we more or less know the answer, but probably you're going to solve it in a second, no? How difficult it is to use OGP from the Java application?
Yeah, let's look into that. That's our demo. Apologies, we're going to do a bit of reverse engineering in our demo. That's my bad. I didn't separate time to do what I usually do. But what we're going to be doing is we're going to use in OJP project here in GitHub. There is what's it called, the enterprise or company name, which is Open J Proxy, right? Under this, there is multiple repositories, right? There is our OJP, which is the project itself. There is our website, Helm charts, and there is this guy here, which is OJP framework and integration. So what this guy is integrating tests with OJP for different frameworks. So if you want to see how to integrate with the Spring Boot, all you need to do, you can come here and you can open the Spring Boot side of it. The app is normally the same app, is a shop cart app. And you can see here like how you integrate with Spring Boot. There is all documentation here. But and you can do it for Micronaut, Quarkus, Spring Boot with Atomicus, Spring Boot with Mariana, distributed transactions. OJP supports distributed transactions, which is an important thing for some scenarios. And so this is a very cool repo to look into. But in terms of documentation, we also have all our documentation is under documents, right? We have here Java frameworks. And here we also have, for the three main frameworks, or the most popular frameworks, we have how-tos per se, or README contents. Now, we could summarize integrating with OJP in 3 steps, right? You modify your connection URL to the OJP pattern, which we're going to be doing in the demo. You remove your connection pool from the project. We're going to demo it with Spring Boot. And you add the OJP JDBC driver dependency to your project. And that's it. 3 steps, right? It should be that easy. Now, to get started with OJP, if you're running it the first time, the easiest way to do it is by running our Docker image of the OJP server. Right? So in the very first page here, the README, it has the steps again, like how do you do you start with OJP? But here it is more generalist, and you can start it as a jar or as Docker. So for our demo, we're going to be starting it as a Docker. This is the latest version released, 0.3.1. We are working on the 0.4.0 beta, which will have a very cool thing, which is SQL enhancement with Apache Calcite. If you've ever heard of Apache Calcite, and we're going to be implementing that in OJP. So let's get started. So we're going to follow the documentation, right? So basically what we're going to do here, we're going to get this guy. We're going to be running our Docker OJP server here. Okay, we have it running here. I have already Postgres running here, but you can find documentation here as well on how to run Postgres. I'm not going to search the documentation right now, but if you go through the documentation, it's not difficult to find. There is, for each database, like what you need to run is basically a Docker command. If you don't find in our documents, you can find online. It's just if I show you here for each database, and you just run in Docker, right? So run. So let's see Postgres here. This is the Postgres one, right? So if you want to run Postgres, that's the one you're going to be using. You can give a name, right? I call it OJP Postgres, but whatever you want to use. One important thing for Postgres, if you're using XA or distributed transactions, you need this parameter, max per transaction. It's not going to work without it. But if you're not using XA, then you're fine without. Anyway, those are the 2 things we want to have running. For the test, I'm going to use that we don't actually need Postgres, but just to give you an idea, if you want to run with Postgres, what you need. Because that test that we're going to be running from the framework project and the repository is H2, so it's in memory. Now the Atomicus and Ariana use Postgres. That's why I mentioned Postgres. If you want to do the distributed transactions ones that we have there, you're better off running Postgres. Now let's just get the project of Spring Boot open, which I probably have it somewhere here already. Let's just open on there. Apologies for that. I should have got this open before the meeting. Why didn't open? So this project's Open J Proxy. Framework integration. Apologies for that. So let me just find where this. I have too many folders. My memory's not great. Why is it not copying that path? There is something here annoying. I cannot see actually that last line. Just get rid of that. Okay. Framework integration. Spring Boot. That's the location. I thought I had it open, that's why I didn't bother before the meeting. But this is actually the main folder I want to put than just the Spring Boot one. Let's get the right one open. This window, no problem. So when I said I will do a bit of reverse engineering is mainly because this is already with OJP, right? So we're gonna test it with OJP, and then I'm gonna remove everything and make it back into a simple Spring Boot project, which is the same steps, just backwards, right? Just gonna save these parameters here. We're gonna talk them in a little bit, and just see what's here. Is it all set? Into this, let's run the integration test, right? So we have orders, we have items, order items, that is a shop cart, right? So we have reviews, users. That's basically this project. I'll show you the project in a second. Let's just run this test here. As we have OJP server running here, we can probably, yes. Yes. Let's just check what's going on in the OJP server. We have here, we've got this name. I usually run it without a name. Let's follow. And the test passed. And let's just run once more. We should see things going through here. And that's awkward. Okay, let me just check what we're seeing here. So we do have it running. Yeah. By default, it comes with a log level error. That's why we are not seeing any information. So that's really only going to show logs in OJP server if there is a mail. So it comes ready for production. So if you need to enable errors and other log level, you need to pass it every point. But basically, these tests are all going through OJP at the moment. And how do they know that they need to go through OJP? So two small things here, right? So your connection URL, it changes to use this prefix here. So the OJP prefix. So if you didn't have it, this would be your connection URL. And that pattern works for any database, right? It's always JDBC, then your database could be MySQL, Oracle, whatever here, and then the rest of the connection to the database server, right? So in this case here, we are connecting to an in-memory database, but we want to connect to Open J Proxy, which supports H2 by default, right? You can work with the H2 in Open J Proxy as well for testing mostly. for production. So what this is telling, first of all, we are telling that we want this connection to go through our proxy, not to go directly to the database. We say where our proxy is sitting, in this case in our localhost port 1059. And this is an optional data source name. So if you have only one data source, you don't need to use this. But if you have more than one, you can name your data source. And we're going to talk about that in a second when I explain the OJP properties. Now, username, password, everything else, you see that we didn't even add any configuration yet to Spring, right? And it's all the same. It's just a different URL pattern. So that makes it very easy to integrate. Now, the driver is different, right? Obviously, because we are now using the OJP driver. And to do that, we do need to put our OJP JDBC driver in the POM XML. So it is here. And a little more in relation to the properties here. Dialog all stays the same. We only need this as well for Spring Boot because we're going to disable HIC-RCP. So HIC-RCP comes with Spring Boot. So as we disable it, we need to give another data source provider, which the easiest one to use is this simple driver data source, which what that does is it opens and closes connections. There is no connection pool anymore. It's just a simple data source. Now, if we look at this high performance, we have two data sources here. One default, that's how it's called, the full one when you don't give a name, and one called high performance, right? What that allows us is in OJP properties, that's something, you don't need to add this for your first test. You're going to get the full configuration, but obviously you want to add, in normal scenarios, you want to add at least the pool sizing, right? Which is what I did here. And that's how you configure things in OJP. You start with OJP connection pool, and then it goes pretty much, you're probably familiar, maximum pool size, minimum idle, connection timeout, all the same configurations you can do in HIC-RCP, you can do here. Now, for different data sources, the only difference is that you can put a name as prefix, and once you put this name here, you can put that name in your connection. That's what we did here, which means we have two different data source configurations, which will result in two different pools in the OJP server. So in this scenario here, we're going to have two pools, one with minimum of 5 and maximum 25 connections, one with minimum 5 and maximum 50 connections. Anyway, we tested already with OJP. Now what we're going to do, we're going to break OJP, right? So let's stop it. Stop. Once it did not stop. Oh, it did stop. Yeah, that's two databases, Postgres and DB2. If we run this again, we should encounter an error. Yeah, they failed because it could not connect. Probably if we look, the core issue here is unavailable, unable to create a request service. Yeah, you cannot find the Open J Proxy server anymore. Now, what we're going to do here, we're going to remove OJP, right? So we're going to make this app becomes the app you have, your Spring Boot app, right? So the first thing here, we're going to remove the OJP driver dependency. We're going to delete this file here. And we're going to return this connection string to what it was before we added OJP, right? So just the H2. The simple driver data source we don't need anymore, because we're going to use HIC-RCP again, and we remove it here as well. One more piece here is in the POM XML as well for the HIC-RCP. You see that we had to put an exclusion here. that's how you remove HIC-RCP. If you ever had to remove HIC-RCP from Spring Boot, that's how you do it. So to run OJP, you need to do this. Now we are reverse engineering this, right? So your project probably looks like this, right? You have the Spring Boot starter JDBC without the exclusion. To put OJP, you need to exclude HIC-RCP, right? That's about it. So let's run the test again. And let's cross our fingers. It should work, right? And it didn't. Let's just see what's going on. What I think I know what it is. It's probably that I think it's still in the class path, because if the OJP the JDBC driver remains in the class path, it might be the case here. I thought maybe we don't have the H2 dependency, but it is there. So let's just do a new build, clean one. Let's start running again. What is this? Let's go to the source. Still looking for. I think I didn't. We didn't change the driver, did I? Still looking for. Yeah, switch. Okay, let's just. I never remember. H2. JDBC. So Google is not that good anymore. In the old days, it would bring this right away. Plus we need now the H2 one, not the we just remove Open J Proxy one. So obviously we can. My bad, I forgot this step. Just 4 steps and I still can forget. Let's run it again. Yeah. So now we are back to exactly how your app looks like, right? So your app starts looking like this, and you need these few steps to make it work with OJP. You need to change your driver. You need to you need to put the OJP prefix and the simple driver data source. You also need to exclude HIC-RCP from your project, and you need to create your OJP properties. For your first test, you don't need that. Like if you just want to play around with OJP, you don't need to set your own properties for the connection pool. You can start with the full HIC-RCP. I think will give you 10 connections top maximum. A pretty good start. So you can start playing around, seeing how it behaves with OJP. Any questions on the demo? That's pretty much the demo. It should be as easy as this, like it's these 4 steps, right? Together running with OJP. And you do have examples here in the documentation for Spring Boot, Quarkus, and Micronaut. Right? Let's say if you get Quarkus, it's very similar. You put the JDBC driver. Quarkus is very nice because they have this unpulled. And so to stop using their connection pool, you just say don't pull connections. It's easier even than Spring Boot. And again, like you change your connection URL, and that should work, right? The OJP properties is when you actually want to set your own properties. Maybe you want to create your different data sources, like I explained. Then you start going into more advanced features, right? But to get started, it's 3 steps in the app plus 1 step, which is running your OJP server. Okay. Hope that's clear enough. Any questions?
I think it was clear enough, Rogerio. I think the demo was clear because the question that we had on how how, let's say, how we can do it, no? For using it and how to do it is just no more than 4 steps: adding the dependency, changing the connection name, introducing another data source to, let's say, replace the Hikari, and also configure the properties. So it's just very straightforward way to introduce and use Open J Proxy, which is kind of a cool way to an easy way to introduce it and using it. So that's very nice.
Yeah, I think so. Like there was a lot of effort on make it easy, right? And more than that, we are very committed to having a lot of tests against it. And you see that we have Micronaut tests, Quarkus, Spring Boot, and then Spring Boot in multiple flavors. Spring Boot alone
Mhm.
with H2 in memory, which is the one that we just modified. That's this one here. But you can see also Spring Boot with Atomicos, with Mariano, for XA protocol, right? The distributed transactions. So these are fully functional projects and with fully functional integration tests. So what these projects do, they pull the latest code of OJP, they build it locally, and they run tests against it. So what that means is every version we release, everything that goes into our main branch is tested against all these frameworks here. And not just that, it's tested against all the databases we mentioned, right? Seven
Nice,
databases in total.
nice.
So we have
There are some,
1,500 tests more or less at the moment.
wow, not bad.
Go ahead, Nacho.
I was going to ask you one of the questions that we receive and also give you the opportunity to drink some water, I
Fire
guess.
ahead, yeah.
Uh, so one of the questions, Anil again asked about for Kubernetes heavy teams, how do you recommend deploying OGP multi-node clusters? So it's a cluster Kubernetes question. If it's a daemon set for low latency or deployment with affinity rules. I don't know if you have any
Uh,
recommendations on that.
Very good question. Very good question. We don't have like we are working still in improving the part of affinity rules and all that. You need to remember that it's usually going to be a stateful set in Kubernetes language because we use gRPC, right? The reality is, and we do low client side load balancing. So our JDBC driver it does load balancing and failover for us, right? We did consider putting a load balancer in front of the OJP servers, but that comes with a lot of costs, right? The first cost is another round trip in the trip to the database, right? And we already put in a round trip, which is the proxy server itself. So we didn't want to do. Another problem is that you don't really get a load balancer when you're using gRPC because gRPC is a multiplex tunnel through HTTP 2.0. And what that means is once it establishes the connection, it's point to point, right? It's a multiplex point to point. But if you put a load balancer in a gRPC architecture, what it will do, it will load balance where the connection goes. But once it's established, it will be there. So at the end of the day, what we decided to go with is the stateful set. We do provide for Kubernetes, if you come here to our OJP Helm, you can use our Helm charts to deploy in Kubernetes. They're going to be deploying the stateful set that I described. Our suggestion is a minimum of 3 servers, three nodes, right? For redundancy. So what's going to happen with the 3 nodes is that you're going to have the clients load balancing. Our JDBC driver will load balancing between them, and it will do that more efficiently because then it has one gRPC connection to each one of them, and then it can send requests in a load balance fashion. And if one of them fail, it will reroute to other servers. One cool thing that we implemented as well is that once you lose one OJP server, the remaining ones in the cluster will compensate the connections that one lost. For example, if you had 3 servers with 10 maximum 10 connections each in the connection pool, and one goes down, the other 2 will raise their connection pools to 15 to accommodate that one that went down. Once that one comes back up, it will relay through the clients to the JDBC driver again that server came back up, and it will go back to the 10, 10, 10, right, to make the 30. So those are cool things that are there. And in relation to Kubernetes again, we are preparing. This is not ready yet. Okay, so don't use it as we are still reviewing this part, but we are preparing an ebook, and the ebook is you can find the current version. So it's not yet a reviewed version, but if you go to our pull request here, there is a pull request which we are heavily using Copilot to write for us. Right? Everyone is using Copilot for everything. But if you come here to the ebook for OJP, there is a pull request open in this branch. And here, if you go to the branch itself, right, you can access the ebook at the state that it is at the moment. And just to the question, right, specifically to the question, there is a chapter here specifically related to deployment. There is a chapter about security. So if we come here, Kubernetes, there is a chapter here about Kubernetes, what we recommend in terms of using the Helm charts, and there's a lot of information here. So I was reading this. This is already reviewed. I think I reviewed up to chapter 10. I'm currently reviewing 11 and 12. So it's 20-something, 23 chapters written by Copilot, and I'm reviewing through it. So this is a good place to go, but basically it's a stateful set, right? You're gonna configure in Kubernetes, and our recommendation is a minimum of three nodes for reliability. And especially you could go with 2 nodes. What I don't like, I think it is bad to go with the 2 nodes, because if you lose 1 node, you're left with a single point of failure, right away. So it's a bit dangerous, I think. I think depends on your setup, how much you can accommodate. And another downside of just 2 nodes would be that, let's say the same example we had before, right? Like that you had 30 connections, let's say maximum to the database. So if you have 2 nodes, it's 15 in each OJP server. If you lose one of those nodes, the other node will compensate to 30, right? You have to double capacity, and that's a large increase in capacity that it needs to accommodate. So with 3 nodes, that increase is less, right? It's just 50%. So that distribution of load is also an advantage. So it's in our view is better to have a little bit smaller nodes, but at least 3. Then you're in a good position.
Thank you. I think it's already answered, I think, and also pointed to this guide. I think probably your colleagues will find more answers to many other questions. I have one question related to OJP. You mentioned, let's say, the benefit of using it and how it reduces the consumption, in the database side, let's say, by not pressuring on that, and also not having. But then the other question I have is, okay, so what OGP requires in terms of consumption? I mean, if we let's say move all the pressure to OGP, is OGP, required that it had a lot of, for example, resources, because it required more CPU, more memory? What are the needs for OGP in terms of?
It's very lightweight. In the test that we did so far, that is lacking a collection of metrics on that. But for example, in these tests here, it was always below 20% CPU. The OJ, there was only one for this test. There was only one OJP server, but it was always below 20% CPU maximum, and memory was stable all throughout the test. We didn't collect, it was a pity. We didn't collect those metrics, but it's something we need to test better. Now, you need to remember this is a gRPC server, right? So basically, it's a very lightweight, very efficient server, and we don't keep anything in memory really. So memory footprint is in all tests we did, is always stable. Now that might change now because of our implementation with Apache Calcite. Because what Apache Calcite will do, it will improve the queries. Let's say you have a poorly written query that has joins that are not hitting the database in the right way. It will improve it and cache it in memory. So there's going to be a slight increase in memory. Our I'm going to speak in the next slides also about the slow query segregation. Also keeps a small cache in memory to keep track of how fast the queries are. But in general, OJP is a very lightweight pass-through mechanism, right? So we don't expect it to spend a lot of resources. In our tests, we use the same pod, the DigitalOcean pod, which is one virtual CPU, very small. So there was this virtual one CPU droplet for the Postgres, and one the same for OJP. And the OJP was honestly, it could have been even smaller for the test. So we don't have a lot of numbers at the moment, Nacho, but our expectation is that it's very cheap to keep OJP.
Yeah, makes total sense. It's just I'm asking because the next thing is, of course, if you reduce the pressure, it's just trying to move it to another place. But if it's true that it's a lightweight component, probably this pressure more or less disappeared and moved back to the clients, no? Because it's basically
that's the goal, yeah. And you're very right, yeah. The main goal, I think, and one of the main drivers of OJP is to remove work from the database, right? Because if you think about all the things we've been talking so far, like, does the database needs to be the guy that orchestrates between parallel works? It doesn't need to be the guy that does that, right? It needs to be the guy that saves data, retrieves data, keeps the acidity, the acid, guarantees. That's the job of the database. Like, bouncing around multiple requests is not his job. Is it his job to do, for example, the circuit breaker? No. So we're trying to remove work from the database so that the database can do more work of the jobs that we are interested into, which is saving data, retrieving data, and keeping the atomicity that we need from a relational database. So surely it moves that pressure to the OJP server, but that is built to absorb that pressure. So one configuration that is important to that, because it really, you can use more OJP servers or less OJP servers depending on your setup. It starts with 200 threads, similar to Tomcat, right? But it's obviously an OJP, gRPC server. But you can change that. So if you want to have fewer but more robust OJP servers, you increase the pod capacity that you're deploying it into, and you increase the number of threads, right? You need to test it. That there is no other way to find the right balance, but it starts with 200 threads each. So if you deploy the way I suggested with these three pods, right, you get 600 threads in the OJP. That means it can receive 600 requests, and then organize them into, let's say in our example, there are 50 connections to the database, right? Serialize them down the stream. So that's more or less the capacity it can take. So it can take a lot. That's what we perceived so far. Like it really can take a lot of load, like any other gRPC server, right? If it's good enough for Google, like, it's probably good enough for
many of us. Yeah, that's right. We have the last question, if I'm not wrong, probably for the session today. And it was Daniel again who asked about it. I think it's the setup of the circuit breaker. So he mentioned circuit breakers block failing after 3 defaults, but how configurable is that per query or per tenant? And that's how does slow query segregation integrate with read replicas? That's a very hard-coded question. Very difficult one, I would say.
The circuit breaker at the moment is only configurable for the whole cluster. We don't have that configuration for it is not very granular yet. But if there is interest from the community, and if we start seeing use cases where people say like, oh, we actually need different levels for the circuit breaker, it's something we can easily improve on. If you do a test and you find out, oh, there is this scenario in our company that would require that, if you bring clear use cases for it, for us it wouldn't be difficult to expand that. We are just being careful to not over configure this, right? Like, we have a lot of configurations, but all of them are based on real evidence that they are needed. So At the moment, is in a basic implementation. You have one configuration. So to use multiple, you would have to deploy multiple OJP servers. That's the way. If you need different configurations for the circuit breaker, you would need to have different OJP servers.
Nice. So I think we don't have any more questions. And I think that's it. I mean, that you did the perfect presentation. If you have something else you want to share, Rogerio?
Yeah, real quick. I know we are a bit over an hour. In because of very good reasons, very good questions, right? So we could go into great detail there. One very cool thing we developed in OJP is this low query segregation. So your conventional pool look like that, right? So your queries compete by lanes, and you can have slow queries in front of fast queries, right? So what we developed in OJP is a cheap mechanism to separate them. So we are capable of monitoring how fast a query is and creating two lanes in your connection pool. And you just need to configure like how much percentage you want for slow queries. By default is 20%, but you can put whatever you want, 50, for example. And every query that's deemed slow will go to those slots and not to the fast slots. So what that means is you always have fast queries running freely without slow queries in front of them. That's important because as you decrease the number of connections, it could become, in some scenarios, it could be easy for slow queries to take over the pool, right? You have a bunch of slow queries running and they take over the full pool. We also implemented the borrowing. So if one of the sides is not being used, is idle, it can borrow lanes to the other. So that's something completely new, completely novel. You're not going to find it in any other proxy. Guys, this is the GitHub, right? Please go there, leave your star if you like the project. Try it yourself. Leave us some money if you want. Produce content about it. There is our Discord there, our LinkedIn as well. Follow us. It's very important for us, the stars, the followers, like engaging with the community, bringing your perspective to it. It's all very important. And just one more slide I think I have. We do give badges to contributor, and we have a OJP champion program. So basically, you get your badges and you climb this mountain here to the OJP champion reward. So if you do anything for the project, from contributing code in the blue line, or testing, or evangelism in the purple, or documentation in the orange, you get your badges, recognition from the community, and your name comes to the wall of fame here. You see all the guys that contributed are here. So you get your name here, and you can post it on LinkedIn. This directly to your LinkedIn. So yeah, that's the way you can help with the project, and that's pretty much it, guys. I think I don't have anything else important. Nacho, I think we can wrap it up.
No, I think we can wrap it up here. I think it is clear. You did an amazing introduction and a nice presentation how it works and the things we can gain as using OGP. So thank you very much for your time. To be honest, Rogerio, I hope to all time you will make it to come to Barcelona. And for the people that been attending and having very good questions, very nice, let's say, atmosphere. So thank you very much for being here. And I hope we will see you in person someday. So thank you very much and have a good day, all of you.
Thank you. Have a good night.
Thank you.
Obrigado, Rogerio.
Obrigado.
Obrigado.
De nada, de nada. Ótimo português.